linear inequality. So first off, what are some inequalities that we know? That'd be like what? Less than, put these in your notes, greater than, plus or equal, greater or equal. Those are some of our inequalities, okay? Turn to this section in your notes. Sorry. Okay, so we're putting those in. It's going to ask you to graph it on a coordinate plane in the with the resulting borderline being solid. I will tell you that our solids are our equals, okay? The solids will always have an equal with it, okay? And then the dashed ones or dotted ones, those are going to be your less than and greater than, okay? So the dashed ones are going to be when we are looking at less than or greater than, okay? So here's the situation, and this is why we need to be able to graph these and not just come up with solutions. So it says, you are buying paperbacks and hardcover books for a book sale. You can spend at most $20. First thing we want to think of, at most $20. Could we spend $25? If you have at most 20. Can you spend 25? No. Could I spend 10? I could spend 5. I could spend $12, right? That's less than that 20. Okay? What are the possible combinations of hardcover books and paperbacks that you can buy? So, and then the question is, how many solutions? Can I buy, if I think of this as my paperback as my X, right? So this is my paperback, and the Y as being my hardcover. Could I buy 1? Is that going to work? So if I'm looking, could I have 1 paperback and 1 hardcover? Yep. I want you to write down 3 more solutions that you can think of, okay? Where we're thinking paperback and hardcover. 3 more. Easy one. If I have if I have just 1 paperback, can I have 2 hardcover? 9 and plus 250. Yep, that works. That's less than 20. So I want you to come up with at least 3 of them. Write those ordered pairs for me. Okay? Ryan, give me 1 more.
2 and 2.
2 and 2. Otto, you have another one?
3 and 2.
3 and 2 is going to work. So the question is, how many solutions are there for this problem? Could I have bought 1 and 0? Is that a possibility? Yeah. Or I could have bought 0 and 1, right? So how many different solutions are there to this problem? There are quite a few. We do not want to try and list all of them. Okay? So we have many solutions, and what we are going to do at this point is we would want to graph that solution. Because there is no way we want to try and write out all the possible solutions, right? There's many combinations. Does this stop at some point, or does it have to stop? This one does, right? Because we can't spend more than $20, right? So if you get something that totals over 20, it doesn't work, right? The 2 books. So at this point, we can leave it like this. So here's, on that next part of your notes, it says this. We are looking at linear inequalities with 2 variables. They can be formed by replacing the equal sign in a linear equation with an inequality. The solution to an inequality in 2 variables is always going to be that ordered pair, x, y, that has to make it true. So it says everything we've just learned about our 3 forms of linear also applies to linear inequalities. It is asking you to check, is 1, 2 a solution to this problem? And is -3, -7? So what I would like you to do is right below here, show me. Is 2 greater than 1 minus 3? And over here, again, we're looking at our x and y, and we're going back to this equation. And I want you to tell me, yes, it's true, or no, it's not. Okay? If I am looking at the first one, Abby, true or false? True. 2 is greater than, if we are looking at it, -2. The next one over here, Devin, what'd you find out? -7? True or false? False. Not a solution, okay? Because -7 is not greater than -6, right? It is less than -6 on a number line. Whereas 2 is greater than -2, right? And if it helps you to think of your number line where you're looking at these and you have -2, you would have had -6, -7, right? -7 is less than, not greater. -2 with 2, -2 is less than 2 as we are looking for. So it now asks you to list one more solution to this problem. So list one more. Give me the x, give me your y that's going to make that true. There is many. There's actually infinitely many. So come up with one more. Write it as an ordered pair, okay? So this part is going to be an ordered pair that makes this equation true. Tanya, what do you have? 6. So 6 minus 3 gives us 3. 10. Could I have 6 and 4? Would that work? Could I have 6 and 5? 6 and whatever that first number is, right? As long as this is greater than, in this case, 3, all of these are going to work, right? So I can come up with many, okay? So if we're just listing one, I just want you to be aware that there are many, many solutions as we look at that. So that's why we are going to graph. And as you look at this next part down, this is on your graph, it says, a graph includes every solution. There are an infinite number of solutions, and they are not all on the line. Rather than drawing 1,000 dots, we have a shortcut, and you are going to shade one side or the other. Step 1 will tell you to graph the boundary line. Usually slope-intercept. But if it's in point-slope, you can graph it at that point. If it's in point-slope, you can graph it. It says it'll either be solid or dashed. Solid is when you have the equal, greater or equal, or less or equal. The dashed lines, the dashed will be when we have greater than or less than. It says you will shade, so when you look down here, as you look at this, as we are looking, the greater or less than is always going to be a dashed line. The line is not a solution. Every point on this line does not ever make this true. Okay? Whereas over here, every point on this line, because it's solid, will make it true. Every point on there is a solution. So you got to make sure you're understanding the difference between your solid one and dashed one. Then it says you're going to shade the part of the graph that includes all solution. It's either going to be on one side or the other, and this is called the half plane. Now, what I have students, when they are thinking of this, is we usually read, if we're going to read this, Joey, how would you read that? Y is without any.
Oh, y is greater than 3 or 3 halves x minus 1.
Okay. Ottawa, if we were going to read this one.
Y is less than 2, -3 halves x plus 1.
So when you think of greater, most people think of greater as being above. Or if you were looking at a vertical line, so when we have a dash, tilted line, above could be this way, that could be my greater. It could also be something like this, that would be greater. If it's a vertical line, where is going to be the greater? To the right or to the left of the vertical? What do you think?
The right.
To the right is going to be my greater. How about if it's a horizontal line? Where should my greater be for a horizontal line when I graph it? Above or below? Above. So add this to your notes. For that greater, anything greater, we should shade above it. We're going to be talking about test points. Whereas, if I am looking at this one and we read this as y is less or equal, when I think of the less is going to be below my line, right? So if I have a negative slope, I'd graph it, shade down here. If it's a positive slope, I'm still going to shade below that line, right? How about if it is vertical? Where should I be shading? If it's a vertical line, I should shade to the left. to the right was greater, right? And if I'm looking at a horizontal line, where would we think is less? Below. Okay? So all of these are ways that help us to understand where we're going to shade. Okay? We're also going to pick a checkpoint. So you are looking at this equation. First thing we look at it, dashed or solid. Because of the greater than, it should be a dashed line, right? So I know I need to have a dashed line. I want to look at this, and because it's in slope intercept, my start point is going to be where, Owen?
-2y. And then
So
0, -2.
0, -2. Okay, so my start point is 0, -2. That's my y-intercept. My movement, or my slope on this one, Hannah, is what? 1/1. So from this point, I'm going to plot, and I'm going to graph a bunch of points, and then I'm going to draw my line. We said initially it should be a dashed line. Like that. Y-intercept, slope. Next thing we have to decide is where to shade. Now when we read it, we think greater should be above. So we're thinking, you know what, it has to be up here. They want you to pick 2 checkpoints. I will ask you in your homework to pick 2 checkpoints. Now, since we think it's on this side, the easiest checkpoint is 0, 0. So pick a test point on each side. We think the side that it should be true should be 0, 0. Is it true that 0 is greater than 0 minus 2? Yeah, that works. We now want to pick a checkpoint on the other side. So we know at this point this is where we're shading. Easy checkpoint, just pick another point. This should make it false. We think the false point should be over at 4, 0. We don't think that this should work. So we're going to plug it into our original equation. 4, 0, right, is our y. Is that greater than 4 minus 2? Is 0 greater than -2? That is a false statement. -2 is less than. So which side should we have shaded on? Above.
Oh,
Right? When we read that phrase greater, just like we just referred to back here, greater is going to be above the line. Okay? So when we look at that, that greater is always above the line. And this one makes sense because our checkpoint worked. Okay? So half of, like the first 15 to like 20 something are all graphing. I've got lots of graph paper, either form up here that you need to do. Not due till Wednesday. So then we go back to, oh, do you remember if it's vertical or horizontal? And these two, we're looking at that first one. X is greater than -1, should be a vertical line. We're talking about it being vertical. The slope would be undefined, right, if we think of slope men. And we were thinking about this one, if we read it as greater, shading it to the right or to the left. So we're going to go to -1, everywhere where X is -1. Abby, what do you think, solid or dashed? Dashed, because it was a greater. So we're going to have this dashed line. Auto, once we put our dashed line to the right or to the left? X is greater. So you're not sure, right? Let's pick test points. Because I know you look back, but I'm going to pick a test point. I'm going to pick 1 point over here and pick 1 point over here, right? So we're not sure, so we know this point is located at -3, 0. This point, easy point, 0, 0. You can ever use 0, 0 for a checkpoint, no matter which side you use it. okay? So if we're plugging in, is 0 greater than -1? Yes. Over here, we were looking at, is -3 greater than -1? This one is true, right? This is false. I don't want to shade where the false point is. And I am okay with your shading being just like that, okay? If you want to totally shade it in with your pencil, by all means do so, okay? So we read the next one. Ryan, would you read B to us?
Y is greater than or equal to 2.
Greater or equal to 2. So I right away know it's a horizontal line, okay? At 2 should be a solid or dashed line, if I'm looking at that, right? Should be solid. It includes every point on this line. And if we're thinking greater, would you think above or below? If we read this as greater, we would think above, easy point to pick above, easy point to pick below. So my point above is 0, 3. My point below is 0, 0. Plug it in and just do a check. Oh, the y point, 3, is that greater or equal to 2? True. Does this make it false? And the reason you actually want to pick 2 points is some of you, when we start working with inequalities, you'll forget that when you divide by a negative, to flip the inequality. And so your problems are going to have to flip. And so then you'll think that you're checking the right one, but you don't go back to the original, and so then you'll have shaded the wrong way. So go back to the original when you do this. So in this case, if I was checking 0 greater or equal to 2, that's false. 0 is less, and so it should have been shaded the right area, okay? We got a little bit more of your notes to do on this one. It says for a party, you can spend no more than $12 on nuts. So if I'm looking at being no more than 12. 2 pounds of peanuts, cashews are 4 pounds. It says write an inequality to model. X is going to be our peanuts, Y is going to be the cashews. Which form would this be the easiest to write in? Slope, intercept, point slope, standard. Standard. Let's write it in standard. Standard form would be, since we're going with our peanuts first, 2x, right? Plus cashews cost $4 a pound, 4y. No more than 12. I can spend $5, I can spend $7, I cannot spend 13. So less or equal to 12. Because it's in standard form, the easiest way is to think of your y-intercept and your x-intercept. Could you rewrite it? Slope-intercept form? Yes. Okay. I'm just going to show you both ways. If I'm looking at my y-intercept, remember that's when x is 0, and I would have had 4y is less or equal to 12. Y would have been 3. 0, 3. My x-intercept is when y is 0, so I would have been left with 2x, because if y is 0, is less or equal to 12. And when I divide by 2, I get 6. Okay, so 0, 3, 6, 0. We are then going to draw a line between those 2 points. And where do you think we should shade, above or below? Less should be below. And again, you could easily pick a point to do your check. If I was writing this in slope-intercept form, I would have had 4y is less or equal to negative 2x plus 12. And when I divide by 4, I would have y is less or equal to negative 1/2 x plus 3. And isn't that what I have here? Down 1 over 2, down 1 over 2. So it works both ways. It can't be in the other quadrants because that doesn't make sense to have a negative pounds of cashews or negative pounds down here if we are looking at our nuts. So as we look at that, that's what our answer should be. Okay. Here, as we look at this one, I want you to take a look and I want you to think which one can it be and which one can it not be and why. Okay? And as I show you this, one of the things I want you to look at is, do they all have the right y-intercept? Each one of them, right? What makes it so that one of them is not right? So when we are looking at these equations, one of the things I might look at is that there's slope in the y-intercept, right? So I'm looking for a slope of 2 and y-intercept of 1. So right away I know B can't be my answer, right? I know that D can't be my answer because it's a dashed line, right? So I look at that boundary line. The other thing I'm going to take a look at is, because it is shaded below, it has to be a less or equal. So the answer I am looking for is the lesser equal, which is choice A, not choice B. And I know on your graph it's kind of hard to show or see that this is the shaded part. So even if you want to shade it a little more on this side, I think that was hard to tell. Like, they look almost the same shade. So, okay. This is kind of important to make sure you're understanding all those aspects of the multiple choice. I had some people just go, oh yeah, I just know which one I can cross off. Again, I'll have this attached on the notes on the daily planner. So if you need to write this down in depth so that it really makes sense to you, please go to the daily planner and write that down. Some of you that just crossed off and you didn't put, oh, the reason this one didn't work is because this is dashed. I mean, that would be a good reason, right? If I'm looking at this one, the reason this doesn't work is this is above the line, right? So the reason that one didn't work is that it was above the line if I was looking at this. The reason this one didn't work, wrong slope, right? So sometimes just crossing off, one of the things I might ask you is like, why? Why didn't that work? And that's kind of what this explanation is down here that some of you choose to write down and some of you don't. When I'm looking at your notes, one of the things I do notice is when I ask you to go back and look at those, some of you, if you don't get all the notes in class, go back. They're attached to the daily planner, and make sure yours are filled in. Make sure you're understanding that. So the last part of the homework you're going to be asked to do is to write these. I want you to notice what is our start point, right? So we're going to write them in slope-intercept form. This one is going to be a lesser equal, right? Here we're going to be looking at a greater than. The reason I know greater is because it is dashed. The reason I know this one is an equal is because it's a solid line, right? So that tells us our dashed and our... I look at the y-intercept. This is at 2, right? What's my y-intercept on this one? -2. What is my slope? Positive or negative slope in that first one? -1/2. Over here, I'm looking at my rise to run. I should have a positive 4x. When you do this on your homework, if you get stuck with that, think about that slope guy, right? Positive goes up, negative down, undefined, 0 slope, right? This is what I'm going to be looking for your answer as you finish. There is a lot of graph paper up in front. Questions 15 to 27 or 29 ask you to graph. Make sure you're showing your work. I know we don't have a lot of time. I have graph paper up here. Try and start this, but know that your key thing tonight is to study for that quiz tomorrow. Go back and study. So we got about 3 minutes, right? We go till 8. So I know there's not a lot of time, but take a look at those.